Hello everyone, this is my second video in this series where I'm using Google's Gemini 2.5 Flash with a custom gem that I have made to learn the NIM programming language while solving Project Euler problems. So today we're doing problem 2. We did problem 1 in the last video, so now we're doing problem 2 in the second video. So let's take a screenshot of this problem and let's work on it from start to finish. So this is video 2. And this right here is what we will be working on. Scroll back to content. Cool. All right, so each new term in the Fibonacci sequence is generated by adding the previous two terms. By starting with 1 and 2, the first 10 terms will be 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even valued terms. Okay, so here's a primer on what Fibonacci numbers are. A Fibonacci number is basically, for any number n, it is a number that is created with the sum of n minus 1 and n minus 2. So here, 1 and 2, there's a caveat, which is that you have to have first two numbers to begin with to have to be able to add the two previous numbers. So we seed and start out with 1 and 2, and then after 1 and 2, we add 1 and 2, and then we get 3. We add 2 and 3, and then we get 5. We add 3 and 5, and then we get 8. We add 5 and 8, and then we get 13, and so on and so forth, and we keep going. So Fibonacci, those are Fibonacci numbers. So if we want to solve this problem in NIM, I think what we're going to need is the ability to define integers, perhaps arrays. I don't think we'll be able to, I don't think we will need to store all the numbers. I have an idea about this that I'll show you in a second. I think we need to be able to define arrays with at least size 2. We need to define arrays with seeds, perhaps, so that'll be 1 and 2. We need to know if our arrays are 0 indexed or 1 indexed, i.e. our NIMS array 0 indexed or 1 indexed. How do we replace numbers in arrays? How do we add new numbers? So how do we go from 1 and 2 to 2 and 3? And how do you define arrays such that they can hold integers to begin with? I think those are the questions we need. So requirement number 3 will be some kind of iterator, perhaps for or while. Let me think, what else? We need the modulo operator one more time. So we had that in the first video as well. We'll need if conditionals, print statements, or echo statements, really. In NIM, they're called echo. And these are not in the order of priority, but we will also need, oh, no, I think that's all we need. All right. I think that's all we need. So cool. So in the NIM programming language, how would I define integers? Okay, var x equals to 10 or var y int x int equals to 20. Okay, so we can either have type inference or we can specify the type. In nim, how do I create fixed size arrays that are these zero indexed? How do I define arrays to hold a specific type, such as integers? How do I replace numbers in arrays? So how to create an array, how to seed it. Oh, right. Array, how do I create arrays with values? So how do I create them with values? So 1, 2, 3, I think that's right. So define size and type, okay, with values, specific type, C, okay, cool. And replace, okay, so this is how you define an array of a specific size, this is how you define them with values, they're zero indexed, this is how you specify type, and this is how you replace. Okay, cool. What iterators are available in nim? Items, pairs, countdowns, countups, and for loops. Okay. What about while? Sometimes you have to press the model a little bit. What about while? Okay, while exists, repeats blocks while condition is true. Please provide an example with syntax. Yeah, okay, cool. How, okay, so we know how to do mod, we know how to do if, we know how to do echo. So let's try this. All right, so nvim problem 2.nim. Okay, so make this a little bigger. I think this is good enough. All right, so define the first two numbers. So to give you a general idea, this is what I'm doing. I'll define an array that seeds 1 and 2, and then I will have a while loop that goes up to 4 million. So going back to our question, by considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even valued terms. So while less than 4 million, get a new Fibonacci number, new, check if it's even. If it's even, add it to this final. Add to final cumulatively, so even to final. So we will need an integer variable here to hold the final number that will eventually go there, and then print this. Right. So, all right. So the first two numbers, define an array with the first two numbers. All right, so what was the syntax for that? Cool. So the syntax for that was var c array. Okay, so it will be something like this. I'm going with 2, int is fine, 1 and 2, so it will actually be this for me, and I want to call it current previous 2, right? So I'm going about this in a way where I will add the current two numbers. So the way the for loop will work is, or the iterator, sorry, the while loop will work is, while less than 4 million, you take the two numbers in your current array, add them to make a new number, and then I will replace the first number with the second number and the second number with the new number. So we will do this: 1, 2, then 2, 3, then 3, 5, and then 5, 8, so that you can have an array with size 2, but then keep going, and then if so long as you can tell if the new number is even or odd, you're good, and keep adding that to the final sum. So, all right, so to do that, we will now do define variables to define variable to hold final sum. So that will be var final sum int. Now build your iterator, or setup iterator, while and the iterator will need a placeholder for the, I'm just leaving a dash here to say that the line continues. That's just something I do. You might have a different convention. For the current Fibonacci sequence. So here are our seed numbers, and while, oh, sorry, I said it and then I forgot to do it. So var current Fibonacci. Oh, that's wrong. Int. All right, so do I need to set current Fibonacci to anything? I don't know yet, but let's try and see what happens. So while current Fibonacci is less than 4, so that's 4, 40, 400, 4,000, 40,000, 400,000, 4 million. So up to, I made this mistake in the last question, so let's make sure is if it's up to or less than. Values do not exceed 4 million, so I think it's up to 4 million. So current Fibonacci equals to previous 2, because they are 0 indexed, as we saw here, 0 indexed, so it will be 2 first and second. And now what we will do is get new number, replace first with second. So previous 2, 0 is replaced with previous 2, 1. Replace second with new. 2, 1 is replaced with previous 2. Oh, no, it's replaced with current Fibonacci. Now, if current Fibonacci is even, which is if it's when it's divided by 2, if nothing is left, then add current Fibonacci to final sum, right? So, but then we see an issue. So 2 is an even Fibonacci number, but it's a seed number that will never be added to the final sum if we use this code. So what we will have to do is seed final sum with 2, because we know it can go there, and this is about this 2 needs to be in there, and this is the easiest way to do it because 2 is also a seed number. So I think that's it. I think then you can just do echo final sum. Any issues? I don't see any issues. So nim C problem 2. I think this is good. All right, so let's do problem 2. And the answer apparently is 4,613,732. That's the answer we got. So we got 4,613,732. I wish I had that in my bank. All right, so let's see if that is correct. So sign in. What's my CAPTCHA? The CAPTCHA is 28277. And the answer is 4,613,732. We got this one correct as well. So green check mark. Smiley face. Problem 2 is done. We reinforced the idea of how to build integers. We learned about arrays and how to make fixed size arrays, how to replace values in arrays, and we learned that they're zero indexed. We learned how to define arrays of specific types. We relearned for loops and while loops, modulo operations, and then if statements, and then we solved problem 2. Now we can move on to problem 3, largest prime factor. All right, so we need to now move on to problem 3 in the third video. Cool.